Say we have an angle here, and it measures 40 degrees. An angle that is coterminal means that the terminal side of the angle, which is our green line here, is going to be in the same position. In other words, we would have to rotate an entire 360 degrees in a full circle to get back to this terminal side. For example, we could take our 40 degrees and simply add 360 degrees to get a coterminal angle of 400 degrees. If you want a negative coterminal angle, we would have to go clockwise the other way from the same terminal side, go all the way around, which would mean to subtract 360 degrees to get to the same spot. In that case, we can do 40 degrees minus 360 degrees and get a coterminal angle of negative 320 degrees. Therefore, if we were starting at 100 degrees and we need a positive and a negative coterminal angle, we can add 360 degrees and get a positive coterminal angle, that's 460 degrees. And to get the negative coterminal angle, we can do the 100 degrees minus 360 to get a negative coterminal angle of negative 260 degrees. What if we started at a negative degree, so this time negative 150 degrees? We can do the same thing. We'll add 360 degrees and get a positive coterminal angle of 210 degrees. And then we can subtract 360 to get negative 510 degrees as our negative coterminal angle. Now, what if our starting angle was beyond 360 degrees? Let's say it was 400 degrees. We could still add 360 degrees to this and get a positive coterminal angle of 760 degrees. However, you may have realized that if we just subtracted 360 to begin with, we would get a positive angle, in this case 40 degrees, which is also a positive coterminal angle. So keep in mind, just because we need a positive coterminal angle does not necessarily mean we have to add 360. In fact, on the way to finding the negative coterminal angle, we're going to have to subtract 360 more than one time. The first time we did gave us a positive coterminal angle. So from there, we're going to start at the 40 degrees we just got and subtract another 360 degrees, so another full rotation, and that gives us negative 320 degrees, which is a negative coterminal angle. The same is true of a negative angle that was more negative than negative 360. So in other words, if we started with negative 510 degrees, instead of subtracting 360 to get a negative coterminal, let's start by adding 360. And that gets us to negative 150 degrees, which is a negative coterminal angle. To get the positive coterminal angle, we need to add yet another 360. So we'll start with our negative 150, add 360, and we get 210 degrees as our positive coterminal angle. Sometimes you'll need to find coterminal angles, but with radians instead of degrees. From the unit circle, we should know that 360 degrees is equivalent to 2 pi radians. Therefore, when we're dealing with radians, instead of adding or subtracting 360, we're going to add or subtract 2 pi radians. For example, if we started at pi halves, we need to add 2 pi. And of course, this is like 2 pi over 1. And to add the fractions, we'll need a common denominator. So we're going to multiply this by 2 over 2, which means we now have pi halves plus 4 pi over 2. Now we can add the fractions. That gives us pi plus 4 pi would be 5 pi over 2. And this is a positive coterminal 2 pi halves. If we want the negative, we're going to have to subtract. So let's start with pi halves minus, we know 2 pi is equivalent to 4 pi over 2. So we'll use the same 4 pi over 2 in order to subtract. 1 pi minus 4 pi gives us negative 3 pi over 2. And there's our negative coterminal radian, 2 pi halves radians. What if we start at 13 pi over 4 radians? We'll still need to add or subtract 2 pi, but if you realize that 13 pi over 4 is more than 2 pi, then that means, like we saw with the degrees, we can get a positive coterminal radian by just subtracting 2 pi. Of course, this is 2 pi over 1, and we need to multiply it by 4 over 4, so we have common denominators. This means we'll have 13 pi over 4 minus 8 pi over 4, which again is equivalent to 2 pi, and that gives us 5 pi over 4. And that is a positive coterminal radian to 13 pi over 4. If we want the negative, we'll have to do it one more time. starting from 5 pi over 4. So we start with 5 pi over 4, subtract 2 pi. In this case, we'll use the same 8 pi over 4. 5 minus 8 gives us negative 3 pi over 4. And there's our negative coterminal. If you're ever unsure about the radians, because those are a little more confusing than degrees, you can always check your answer by converting between radians and degrees, which is something you need to know how to do anyhow. We know that 360 degrees is equal to 2 pi radians. So if we divide both in half, that means that 180 degrees is equivalent to pi radians. And that's the conversion we're going to use. So when we're converting, we'll either multiply by 180 degrees over pi or by pi over 180 degrees. So if you wanted to make sure that 13 pi over 4 was coterminal with 5 pi over 4, but you'd rather do that in degrees, let's first convert 13 pi over 4 into degrees. So we'll start with 13 pi over 4. And again, we're going to use one of these two conversions. And it's easy to remember which one to use, because if we had pi in the numerator, that would multiply by pi, and we'd end up with pi squared, which really doesn't make sense. We need the pi's to cancel out, because we're going from radians to degrees, and degrees do not have pi. So we'll multiply this by 180 degrees over pi, and we know the pi's will cancel out. Therefore, we just need to multiply 13 times 180 and divide by 4, and that gives us 585 degrees. Now, in our original problem, we subtracted 2 pi, which is equivalent to 360 degrees. So let's go ahead and subtract 360, and that would give us 225 degrees. That should be equivalent to 5 pi over 4, but we can double check. This time, let's convert from degrees to radians. So if we had 225 degrees, we can put that over 1 since it doesn't change anything. And I want to do that because we're multiplying by another fraction. This time, we're going to multiply by pi over 180 because we're going from degrees to radians, and radians is going to have the pi in there. So we'll multiply by pi over 180. And if we reduce the 225 over 180, we would end up with 5 over 4. And don't forget, we still have the pi on top, which did match up with our 5 pi over 4 from above. And then finally, if you wanted to check that negative 3 pi fourths was also coterminal, we would take 225 and subtract 360. And that would give us negative 135 degrees. And if you convert that to radians, you would get negative 3 pi over 4. Thanks for watching. If you found this video helpful, please smash that like button and subscribe for more videos.